Greetings and welcome to Unit 15, which is about taxonomy table. Now, in the last unit, we understood the nature and importance of affective and psychomotor domains to learning, but we also said as yet we do not have adequate methods and processes to integrate affective domain learning along with the cognitive domain learning. Main outcome of this module is understand the importance of taxonomy table in attainment of alignment among outcomes, assessment and instruction. Note that there are three elements of any course. One is outcomes. What should the student be able to do? That is outcomes. Then we should be able to measure that attainment. Whether student has attained that or not, outcomes is done through assessment. And the third one is I must facilitate the students in my class to be able to perform well in my assessments. Through that we are attaining the outcomes. That is broadly. So, any course has these three elements that are you should be able to view a course in terms of these three elements: outcomes, assessment and instruction. And in doing so, the taxonomy table is a useful tool. It does not substitute for what you want to do, but you can use it for a variety of purposes in your instruction, either locating the outcomes at the right level or making the assessment in alignment with outcomes, or planning instruction, making sure that your instruction is in line with what you wanted your student to be able to do. So, this is broadly the outcome of this unit. Okay, to recap, cognitive domain has two dimensions, namely cognitive processes. We also call them levels. In literature, cognitive process and cognitive levels are used interchangeably. Then you have knowledge categories. Now, what we have is there are 6 cognitive processes and 4 general categories of knowledge, 6 and 4. And courses in sciences, mathematics, humanities, social sciences and management, because we have courses in all these areas in an engineering program, and they do constitute something like about maybe 20% or even more in an engineering program, and they are concerned with only 4 categories of knowledge. So, if you are looking at courses in sciences, mathematics, humanities, social sciences and management, you need to worry about 6 cognitive processes and 4 general categories of knowledge. So, why not we put them together in a table with 6 rows of cognitive processes and 4 categories of knowledge that can serve as a tool with, as we said earlier, with several issues of teaching and learning. So, it is a simple table created. Okay. That is what it is. The cognitive processes are remembered through create, and knowledge categories of factual, conceptual, procedural. For example, each one of the cognitive process is associated with a set of action verbs. Any statement that you make about outcome will start with some action verb belonging to one of these cognitive processes, and this cognitive process deals with some elements of knowledge, and elements of knowledge may come from one or more of these 4 categories. That is broadly the purpose of taxonomy table. Let us move on to some features of this. If you look at a cell of the taxonomy table can be numbered by its cognitive process 1 to 6 and its knowledge category 1 to 4. So, you can have a cell, let us say you are here. So, what happens, this cell is 2 comma 2. When it is 2 comma 2, that is you are in understanding the concepts of some concepts that you are stating. Okay, that is what it is. So, I can label this as 2 comma 2. Similarly, this will be 3 comma 2 or this will be 3 comma 3 and so on. Okay. So, we are labeling we are able to identify a cell, and in addition there is hierarchy among cognitive processes. What does it mean? Anything that you create is higher level than evaluate, evaluate is higher level than analyze and so on. So, what happens if I identify an activity here, let us say apply and procedural, then the cognitive activities in understand and remember are implied. That is, I do not have to separately identify these as cells of our concern. If I write something here, or if I write an activity, identify an activity here, then it can be expected all the activities related to these 4 lower level categories are implied. I do not have to separately identify them. For example, an activity, let us say in the analyze, is of an activity of higher complexity compared to an activity, let us say, in understand. So, as you keep moving up this cognitive level hierarchy, the activity can become more and more complex, as we call it. It is not the complexity should be differentiated from the difficulty. I can have a very difficult activity even here, which is intellectually is a lower level activity. For example, if I want to call give me the capitals of all the South Asian countries, I may or I would consider it is difficult, but not complex. Whereas an activity here may be simple, not that very difficult, but it is higher, it has a higher level complexity. So, the two words that one has to be familiar with, complexity and difficulty. Because unfortunately many teachers consider complexity synonymous with difficulty, and they say they somehow prevent or eliminate complex activities from actually instruction and assessment, and that would be doing a great disservice to the students, because you can give simpler problems belonging to higher cognitive levels and they will not become difficult, but students should experience these complex activities. So, one of the things to learn is that complexity and difficulty, we will elaborate more when we look at the issue of assessment in a later module. Now, in case of engineering courses, we found that we have 4 additional categories of knowledge. So, now you have, we call it ABV taxonomy table, Anderson Bloom Vincenti taxonomy table. It will be 6 by 8 table, 6 cognitive processes and 8 categories of knowledge. And the features of ABV table are the same as those of AB table, that is in terms of hierarchy, complexity as well as difficulty, all those features are the same in ABV table as well. And how does the table look? The table looks like you have the same 6 cognitive levels, 4 general categories here and then 4 categories specific to engineering. Now, where do the engineering science courses come to? Because engineering courses are different from engineering science courses. What are engineering science courses? Engineering science courses examples are fluid mechanics, thermodynamics, electromagnetic theory, network theory, aerodynamics. You call it, there are several such courses. Each branch has at least 4 or 5 engineering science courses. They directly, as they are offered right now, they do not address the 4 categories of engineering knowledge. Then the issue comes, should I classify them under the earlier AB taxonomy table or ABV taxonomy table? Which one should I deal with? But an engineering a teacher of this engineering science courses may choose, because of his interest and passion for engineering, may choose to address some categories of engineering knowledge even in engineering science courses. So, what happens? As of now, we will consider 6/8 ABV taxonomy table is applicable to engineering science courses as well. If I choose to deal with the course purely as a science course, then I am ignoring, I am not looking at this 6/4, that is half the cells, I am not putting any activity in that. That is what it means. But because some people may want to use, so we will say 6/8 ABV taxonomy table is applicable to engineering science courses as well. This is a position we are taking. Now, once again, to reinstate, the three elements of a course are course outcomes, representing what the student should be able to do at the end of a course, assessment of the course outcomes through assignments, tests and examinations. Assignments can be many, tests can be many varieties, and instructional activities to facilitate the learners attaining the course outcome. Okay, these are the three elements of this, and these three elements should be in alignment with each other. That is what we are coming to. Alignment means assessment should be in alignment with the course outcomes. For example, if I want my student should be able to design, let us say, a complex circuit, I cannot merely ask him, assess him only in terms of does he understand the physics of the devices that are used, or given a circuit what does it function. I cannot limit my assessment only to those. Assessment should include making him design some complex circuit. That is what we mean by alignment. Similarly, instruction should be in alignment with the assessment. If I want my student to be able to design a complex circuit, I must tell him how to design and actually design some complex circuits in the class, taking realistic specifications of the same. And to ensure that the proper alignment takes place, an element of a course can be tagged by its cognitive level. By looking at its action verb, we can say what cognitive level does it belong to, and similarly we can also identify the knowledge categories. Remember that in any element of the course, one may be dealing with more than one knowledge category. That we will elaborate more on the following units when we start writing the course outcomes. Based on the tagging, an element can be located in one or more cells of the taxonomy table. Depending on how you tagged an element, for example, I say it is apply and conceptual. So, I can immediately put it in the particular cell of the taxonomy table, which will apply will be 3, conceptual is 2. So, it will be 3, 2 cell of the 6/8 matrix table. Alignment among elements of a course means that I am putting all the 3 elements in the same cell of the taxonomy table. That is what we mean by alignment. Let us look at this. Alignment in ABV taxonomy table, we have put a 6/8, and here CO means course outcome, AI is assessment items, IA means instructional activities, what we do in the classroom or laboratory or through any other type of interaction, whatever mechanism that you have, direct teaching or flipped classroom or online, anything that you talk about. Instructional activities means in some kind of interaction or knowledge transfer from the teacher to the student. Now, if that means if CO3 is located in understand and procedural, your assessment items, that is assessment items include assignments, tests and examination. All of them are located in the same cell, okay. And then my instructional activities also are in the same cell. When all the three are together in the same cell, we consider we have a perfect alignment. That is what we mean by alignment. For example, if CO3 and IA3 are in the same cell, but AE3 somehow belongs to, let us say, remember and factual. I ask some definitions and I ask him to reproduce a theorem, then it becomes AA3 has moved here, AA3 is here. If it is so, my CO3 is here, my assessment items are here, then obviously there is no alignment between my outcome and the assessment items. That is what we mean by alignment. Now let us look at other things that happen as of now. The issue is this: if I have my CO4 and instructional activities are also in this here, but what happens is I have AA4 here and some AA4 is also here. So what does it mean? My assignments or test items are not in the apply category, but they are in understand and remember category. While these are related to CO4, that means the items that I am asking are relevant to CO4, but they are not in alignment with this. So that is why the alignment of these two is lot less than if they are here. For example, if I am still my outcome is related to solving a certain type of problems or applying certain procedures, but I should know what the procedure is and what the theory of that is, and I must remember some facts. So there is some scope of having items here, having test items here, but there is no excuse for not putting AA4, some of the AA4 in this cell. In this is not acceptable, while still that is partly acceptable, but not having any AA4 here is totally unacceptable. And unfortunately that is what is happening in majority of the question papers that people design, that they seem to be relevant. I ask some questions about the same topic, but not at the level, cognitive level that a student is required to learn. Now you have another case, you have CO5 is in analyze conceptual category, but I have my assessment items as well as instructional activities are all at the lower level activities, and this is total, because instruction itself is not doing anything to make a student analyze. Then CO5 itself is, that is in terms of implementation, it is in terms of implementation itself, it is a failure. Okay. So both these things, both the types of things are being done, and a teacher should avoid this, and that can be easily identified, because sometimes we do it inadvertently. When I design a question paper, depending on the situation, I may forget to include some items at the which are in alignment with my selected CO. To avoid all that, we can tag each assessment item, and based on that we can verify whether we have adequate number of items which are in alignment with the stated CO. So, that is what we have explained, that not having instructional activities and assessment items at the same level as CO is not acceptable. So, proper alignment requires course outcomes and related instructional activities should be in complete alignment. They should be located in the same cell. But remember that both instructional activity as well as course outcome statement, when I put it at a particular cognitive level, both the knowledge elements of the course outcome and cognitive processes at the lower level are considered to be taken care. So, when I am trying to a higher cognitive level activity, my instructional activity will introduce the terms and explain what the term means and what the underlying concept is, and finally make him do at a higher cognitive level. So, to that extent my instructional activity, which is in complete alignment, automatically involves the lower cognitive level activities. Coming to assessment, while some small percentage of assessment items can be in cells representing lower cognitive levels less than that of a given CO, significant percentage of assessment item should be in the same cell as that of CO. This is a very major consideration that one has to look at. We will look at that more when we are trying to write about CO, writing COs and CO attainments, and also it will come in our next module on course design. So, what does the taxonomy table do? It can facilitate achieving a specified alignment among the 3 elements of a course and eliminate chance occurrences. As I mentioned, by properly tagging and locating them in the taxonomy, in proper cells of the taxonomy table, and subject it to peer review as well. So, by discussing with peers, we can make sure that we are not overdoing something or underdoing something. That is the great advantage of using a taxonomy table. It is an easy way to communicate between communication between the peers. It can help in the design of well structured test item banks, and consequently the validity and reliability, 2 important properties of assessment, can be achieved. While we state here, that means you can design a good test item bank and also ensure validity and reliability. This we will be elaborating only in the next module on course design. It can also serve as an effective tool for organizing a direct or automatic intelligent tutoring. If tutoring is one-to-one instruction, you make a student to do some activity and then you interact at one-to-one level, and if you find the student is unable to do that, the taxonomy table can help you in say, okay, what is the next activity that I want to give him so that he can perform this activity properly. So, we go cognitively one level lower, and you must be able to plan some activity at the next lower level for him to kind of solve, and for us to understand where exactly there is a deficiency in his understanding or ability. So, we have used it extensively in planning intelligent tutoring. So, taxonomy table can serve all the 3 purposes. You have before you 6 by 8, 48 cells. Any course that you are dealing with, I am sure that you are unlikely to use all the 48 cells. So, whatever cells that you consider are relevant to the course that you have taught or familiar with, write 1 or more assessment items that can be tagged and put in that particular cell that you have chosen. So, it could be let us say in 6 by 8 48 you may be dealing with 12, 16 or 20 depending on how you look at the course. You can identify all the cells that are relevant, and for each identified cell you write one or more assessment items, okay, questions, something like that. And in the next unit we understand how to write outcomes of a course within the framework of Anderson-Bloom-Vincenti taxonomy. That is our practically the goal of this particular module itself, how to write course outcomes for a course in the framework of ABV taxonomy. Thank you very much.